Good morning, children. In addition to what we had already done in the last week, in my last video, I had actually given you the differences between the two kind of solid. One is amorphous and the other one is crystalline solid. Now we'll restrict our study to only crystalline solid. Now the whole chapter is about crystalline solid, or in short we call it as crystal. Now what is a crystal? Now, before we understand what a crystal is, we have to understand what is space lattice or crystal lattice. Now, for that, to understand what is a crystal lattice, what we'll do is first we'll go for a definition of crystal lattice. Now, as you can see in the definition, it says that it is the arrangement of points. Now, what do we mean by this point? Now, here the point which is referred to here in the definition, what does it mean? Now, since every crystal is made up of points, now here when we say point, we mean to say it may be atoms, or it may be molecules, or it may be ions. So that means whether it is an ion or an atom or a molecule, sometimes more than one type of constituent particle may be present in a crystal, then we'll consider that all these points or these three ions, molecules and atoms are spherical. Now keep in your mind that now points, whenever we refer to points, think that they are a sphere like a ball. These points, now when they are arranged in three-dimensional space, I hope you understand when we talk about three-dimensional space, a length, a breadth and the height. Like for example, a sphere is three-dimensional, cube is a three-dimensional, cuboid three-dimensional, cylinder three-dimensional. Now this three-dimensional space, how these particles are arranged, that means when we are talking about ions, molecules and atoms, how are they arranged in a three-dimensional space? These very particles which are there, when they are arranged in this three-dimensional space, that very arrangement is what we call as the crystal. That is why, as you can see in the definition, crystal lattice is the arrangement of points in three-dimensional space representing constituent particles in a crystal. So that means it is all about arrangement of atoms, arrangement of molecules, or arrangement of ions. So how are they arranged? They may be arranged in such a way that again they will form a cube, or they may form a cuboid, they may form a prismatic shape. So there are different kind of shape. Gradually we will be seeing what different kind they can form. Now the smallest unit of a crystal, now think about a crystal. A diamond is a crystal, a sodium chloride is a crystal, then likewise so many different crystals we can think of. Now every crystal are made up of small units. Like for example, in biology also you are learning about cells will combine together to form a tissue, then again different tissues actually combine together to form the whole human body system. In the same way, a crystal is also made up of the smallest unit, and that unit is what is called a unit cell. Now there are different ways in which we can represent a unit cell. There again, if you look at the definition of unit cell, the smallest repeat unit of a crystal structure which when repeated, or which repeats in all the three dimensions to form the crystal. Or you may also say it something like this: a unit cell is the smallest unit of a crystal which when repeated again and again gives the crystal of the given substance. Meaning, like for example, if you are repeating a cell, it is almost like a building block. Think about a brick. When a brick is repeated again and again, 1 2 3 4 5, that way, when the your bricks are repeated, that will give rise to a wall, and again different walls will again combine together to give you a house. That means we say that the brick is the building block. Same way, this very unit cell is the building block of a crystal. Now think about a diamond. Diamond is made up of different blocks, small units. Now don't forget that smallest unit of a diamond or a sodium chloride, which together when it repeats again and again. Now if you ask me how many times it should repeat, it may repeat millions of times, it may repeat hundred of times. So that repetition, that smallest block, smallest unit which has to be repeated again and again to give rise to a crystal, that is what is called unit cell. Now if that is so, then again I am repeating, unit cell is the smallest unit which when repeated again and again will give rise to a crystal. So that is what is the meaning of unit cell. Now in a unit cell, Now think about the smallest and the easiest unit cell that you can think of is cubicle. Think about a cube. Now when I'm talking about a cube, you know that you have come across different kind of cubes. You know a cube has all the length and the breadth and the height equal. That is what a cube is. Now if you are thinking about one box, even a chalk box which is cubical or a cuboidal has a length and the breadth and the height, but then for a cube all length, breadth and height are same, and for a cuboid length, breadth and height they are all different. Now we have in a unit cell, we call it as parameters. Unit cell are recognized by the parameters. There are mainly two kind of parameters. One is parameters of sides, that is length, breadth and height, and the other one is the parameter of angles. That means if you are talking about the unit cell, in that unit cell here, now look at that unit cell. Now let me point out here the first parameter. The first parameter, like this is not perfect cube, as you can see it is tilted. Now this first parameter is the parameter of length. Okay, here it is, which is represented in this diagram in terms of a length. So that means how can one unit cell be different from the other unit cell? You know, we'll recognize it by these parameters. The first parameters of sides and the second parameters of angle. Okay, here it is a, that is the length. Second parameter, as you can see from here to there, that is what is breadth, which is represented, you can see here by b. This is what is breadth. This is the breadth of this unit cell. Whereas the third one is height. What is the height of this crystal, which is represented here by c. So that means the first parameter, parameters of sides, represented as a, b and c, or we can simply call it as length, breadth and height. And again, different unit cells are different from each other, and because of the fact that they may vary with each other with respect to a, b and c, or length, breadth and height. But sometimes, you know, one unit cell may differ from other unit cell, that is of another crystal, with respect to this a, b and c, but sometimes they may be very similar. A, B and C for the two unit cell of two different crystal may be same, but still they will be varying with each other. We'll be able to identify them that they are different from one another with respect to the second parameter, and the second parameter is what we call as the angles. Now you can see this, that you see here, this line as well as this line, these are what we call as edge of the unit cell, edge. There are different edges. Now in between these edges, two different edges, they make an angle with each other. Now how do they make an angle with each other? Okay, now if I am talking about the angle made between height, okay, here this is what is the height, this is the height of this unit cell, and the breadth of the unit cell, this is the breadth of the unit cell. Now the angle which is created here, angle between the, again I am repeating, between the height and the breadth is what is represented by the angle alpha. Now you can see here angle alpha. So between the height and the breadth, the angle which is created, how much is the angle created between these two edges? That is what is alpha. Then now the next one is the angle which is created between the height. Now again, here is the height, this is the height, and this one is the length. Now the angle which is created here between the height and the length of the two edges of the unit cell is what is represented by beta. You can see here beta. Whereas the angle which is created between the length, yeah, this is the length and this is the breadth. So this angle which is created between the length and the breadth is what is gamma. That means two unit cell will be differing with each other with respect to this, maybe with respect to alpha, beta and gamma. Yes, they may also differ with one another with respect to a, b and c, the three sides, that is length, breadth and height. But if that length, breadth and height is same, or alpha, beta may also be same, but then gamma will be different. That means we will be able to identify two different unit cells from one another with respect to either a, b, c, or with respect to alpha. Now what you see there in the diagram is a crystal. This whole is, that diagram that you see is the representation of a crystal. This one is a crystal, but this crystal is made up of small unit cell. Now there it is, the colorful picture that you see here, this is what is in fact a unit cell. Here you can see one unit cell. This very unit cell, many such unit cells are there. Here one unit cell, here another one, here third one, here fourth one, here many unit cell is what you see there. That means many unit cell will they repeat themselves to form a crystal. As you can see, that unit cell that is which is colored is what same kind of unit cell is many. In fact, if you I precisely tell you that there you will see altogether there are 8 unit cells for this side and for the other side. 8 unit cell is what you see there in that crystal. Now again, you can see the smallest repeating unit that shows the symmetry of the pattern is called the unit cell. This is what the unit cell is. Now if that is, then this unit cell, how many different kind? Based on the two parameters that we discussed with respect to your A, B and C, or with respect to alpha, beta and gamma, you know that what you see there in the screen is 7 different kind of unit cell. In the first one, this is what is perfect cube. As you can see, your A equal to B equal to C, that means length, breadth and height, they are all same, equal. Then your alpha, beta and gamma, all of them are equal to 90 degree. That means the angle between the length and the breadth, the edge of length and breadth is also 90. Then from breadth to height is also 90, and height and length also is 90. So alpha, beta, gamma, all of them are equal to 90 degree. As you can see, this is what is simple cubic. Such kind of crystal is what is called simple cubic. Now all 7 kind are different from one another, either A, B and C difference, or you will find alpha, beta and gamma difference is what you see. Then the second one is what is call it as tetragonal. In tetragonal, A and B are equal. So you can see A, this and this is same, but height is not same. As you can see, height is different. So that is why A is equal to B, but A and B, they are not equal to C. Whereas alpha, beta, gamma, all of them are 90. Similarly, the third one is orthorhombic. You can see there in the screen what is the difference between all. So then you have rhombohedral, then monoclinic, then you have triclinic, hexagonal. In all these cases, you will just look at the parameters. In that parameter, what you see that either A, B, C, they may be same, they may be different, but this 7 kind, they will be differing from with one another with respect to either A, B or C, or they may differ. If A, B and C may be same, but then again they will be differing from one another with respect to alpha, beta and gamma. So that is what you have. Now based on the arrangement of particles, again I am repeating, when I say particle, I mean to say the point, lattice point. Roughly we categorize our unit cell into 4 different kind. They are primitive, second one is what we call as body centered cell, third one is what is called face centered, and the last one is what is called side centered cell. Okay, but side centered cell doesn't have too much significance. In fact, we will not be discussing much about that one, but especially your syllabus in class 12 will be discussing about these 3. That is why even in the representation you will see only 3 type is what I have picked up. So primitive, body centered and face centered, but don't forget there is also one more type which is called side centered cell. Now these 3, okay, let's discuss only these 3. These 3 are different from one another with the respect to the arrangement of sites, arrangement of crystal particles, points. Now when I told you a little while ago about points, I said that points means ions, molecules and atoms. Now what you see here in the diagrams, this blue that you see here, blue dots that you see, in the second one the green dot, and in the third one the red dot. Now all 3 of them are cubical. As you can see the structure, if you look at them, all of them are cubes. But how are the particles arranged? So based on the kind, based on the type of the pattern in which these particles are arranged in a cube, our cubic cell is divided into these 3 types. Now think about a cube, and a cube has altogether 8 corners. Now when I talk about corners, where all the edges are meeting, that is what we call corner. And this, look at this first primitive one, 8 corner, 1, second one here, third one here, fourth one here, fifth, sixth, seventh, 8. These are the 8 corners. Now if the particles, that is ion, molecules and atoms, if they are present only at this 8 corners of a cube, then such kind of unit cell is what is called primitive unit cell. As you can see, in the bracket is represented by P. P means primitive. Again I am repeating, the first kind of unit cell is primitive. Now in a primitive unit cell, what we have the 8 particles, constituent particles occupying the 8 corners of a cube. Then we say that the cell or the unit cell is primitive. Next, now let's go to the next structure now, body centered. In a body centered, in addition to the 8 corners, now already 8 corners are there. You can see 1 2 3 4 5 6 7 8, 8 corners here, 8 corners already there. Now the particles are not only there occupying the 8 corners of a cube, but there will be one solid particle which is be somewhere in the middle. Here you can see in the middle of a crystal. This is inside the body of that unit cell. Inside it is in the middle. So in addition to the 8 particles, if you have one more particle present there in the middle of the body, that is why the name is what is body centered, and usually we represent this by the symbol I. Again, I am repeating here only 8 corners in primitive, but here in addition to the 8 corner you also have one particle in the middle, and that is why we call this one as a body centered unit cell. Then here coming on to the third, it is called face centered. Why face? Because now think about a cube. You can think about a Ludo cube. A Ludo cube have altogether, you know, that 6 faces. Like that's why we say 1 2 3 4 5 6. 6 faces are there. Now what is a face centered unit cell? In a face unit cell, again same, in addition to the 8 corner, 1 2 3, then 4, here 4 corner, 5 6 7 8. In addition to this 8 corner, there will also be particles at the faces, at the 6 faces. Now let me show you where the 6 faces are. Here this particle is in one face, this face. This is on the other one, second phase. This is there on the third phase. This is on the fourth phase. This is on the fifth phase, and this is what is on the sixth phase. That means altogether 6 phases are there. So in addition to the 8 corner, that total particle that you see, total particle that is visible to us here is 8. Even though it is not 8, later on you will see that this 8 particle actually is equal to 1 particle. That we will come to that. Similarly here also, even though you see 8 plus 1 9, but actually it is not 9, it is something else. In fact, it is 2 particle. Here also you can see, in case so many you see 8 in the corners and 6 at the faces, 8 plus 6 is 14. Actually it is not 14, it's something else, but that I'm coming to that a little later. But these are the 3 different kind of lattice types, or let's call it as lattice crystal. So and do not forget, here I am discussing only about cubical crystal, cubical, simple cubical crystal. The first one is again primitive, only 8 corners. Second one is 8 corner with rest, in addition to the 8 corner, one in the middle. And here in addition to the 8 corner, there will also be particles at the faces. Now if that is so, then the 3 different kind of cubic cells that we saw just now, there a primitive one just now you saw in the diagram, atoms at the corners of the cube, each of them, each atom is shaped by 8 unit cell. Now I think it may be a little confusing to you, what is the meaning of this one? Each atom is shaped by 8 unit cell. Yeah, for that I'm coming to that, how one which is there at the corner, and do not forget, one particle that you saw at the corner is being shaped by altogether 8 unit cell. What you saw previously was a diagram of 1 unit cell, but that 1 unit cell had 8 corners, 8 particles what you saw, but that one particle which is present at one particular corner is being altogether shaped by 8 different unit cells. Because if we are talking about 1 unit cell here, then another one will be here, second, third, fourth, fifth, sixth, seventh, eighth, altogether 8 such unit cell will be sharing that one corner. That is why one corner is what is being used up by 8 units. This is what is the meaning of that 8 unit cell. Similarly, body centered, you know, in addition to that 8 corner, again 8 corners means one corner will be used by altogether 8 unit cell, and in addition to that, one particle will be there in the middle of that body. That middle of the body, in the middle of the body which is there, it is exclusively belonging to that unit cell only. So that is what is your body centered. And as you saw in case of the face centered, in addition to that 8 which is there in the corners, which are being one particular corner being shaped by 8 unit cell, there are also altogether 6 faces, and those 6 faces also had particles. But then don't forget one phase. If this is one phase, if this is one unit cell, one phase, then another unit cell will be attached. So that means one particle that you see in one phase is being shaped by 2 unit cell, one unit cell this side, the other unit cell the other side. So 2 unit cell, one, again I am repeating, the one particle which is there in the phase will be shared by that unit cell as well as also by the other unit cell. So the one that is there in the face. Now what I want to say actually is that corner ones, the particles which are there at the corner, the one particle that you may see it, but then that one particle is being shared by altogether 8 unit cell. Similarly, in case of body centered, the one that you see in the middle of the body, that is exclusively belonging to that unit cell only. But in case of face, in addition to the corners, the one that you see in the face is being shared by two altogether, 2 unit cell. Now, how actually the three different kind of unit cell that you saw are represented in terms of dots. Here it is 8 corners, but when you stack them together, here it is 8 corner 1 2 3 4. This is what is simple cubic 1 2 3 4, 1 2 3 4, then 5 6 7, one place over the other one. Such kind of arrangement is what is there, and this is what is simple cubic. In case of body centered, now you can see in addition to 1 2 3 4 5 6 7 8, here it is 1 2 3 4 5 6, then there in that corner 7 and 8. In addition to this 8, there is also one which is there in the center, body center. This one that you see is here, so body centered. This is what is in the middle. So altogether what you see is 8 plus 1 is what you see. So this is how the arrangement is. This is what is three-dimensional. Very nicely it is represented in three-dimensional form. Then here, in addition to the 8, 1, 2, 3, 4, 5, 6, 7, 8 at the 8 corners. So here it is 8 corner 1, 2, 3, 4, 5, 6. Now the faces here, this face 1, 2, here that is how it is. This is in one face on the right side, this is on the upper face, this is on this face, this is on that face, not visible all, but then altogether 6 faces. In addition to the 8, there will also be those 6 particles on the 6 faces. Now, a little while ago I was telling you that the one which is there at the corner or the one which is there at the faces. Okay. In this diagram, the first diagram that you see, all together you will see 8 unit cell. Okay, let me show you where the unit cells are. This is one unit cell, this whole thing. This is the second one, this is the third one, this is the fourth one. Then same way lower side. Yeah, fifth one, sixth one, seventh one there, and eighth. There are altogether 8 unit cells. Now let's talk about the particle at the corner. If one particle is there at the corner, then you know that there are altogether 8 different unit cells which is using this corner. Okay, now that is very nicely represented by this unit cell. Now look at this purple ball. This purple ball is being shared by 8 unit cells that you see in the diagram. This purple ball belongs to this unit cell also, to this also, this also, this. That means altogether 8 unit cells are using this ball, the one which is there in the middle. That's why even though in a unit cell you may see that in a unit cell, here if I am making one unit cell, if you see that in a unit cell, you may count it as 8, 1 2 like this, 1 2 3 8, but actually it is not 8, because you know this ball is being altogether used by such 8 unit cell. That is why this one ball, if I count, then I'll not count as 1. In fact, I'll count this ball as 1 by 8. Now why am I counting it as 1 by 8? Because that one particular ball is altogether used by 8 unit cell. Similarly, the ball which was there in a face centered, we discussed about one face center. Look at this second diagram. In this face centered diagram, one ball is used by 2 unit cell. That means this one ball is not 1. So if I'm talking about one ball which is being used in one of the face, now if I'm talking about one of the face, okay, here if this is the face that it is using, but actually this doesn't belong to one exclusive one face, it belongs to 2 faces of 2 unit cell. That's why this ball is not counted as 1. In fact, this ball for a face is what is counted as 1 by 2. So that means any ball which is there at the corner will count that ball as 1/8, not one ball. We'll count it as 1/8 because 8 unit cells are using it. Whereas any ball which is there at the faces will count not as one ball, but rather will count it as half. We'll count that as half ball because one ball is being used by 2 unit cell. Now there you can see 8 unit cells sharing, the other one is shared by 2 unit cell. Now this is another 3-dimensional representation of this one, 3 different kind of unit cell. The first diagram that you see here, corner ball. Look at this corner ball. Look at any one corner ball. So this is only 1/8 of a ball. This was in the corner. So altogether such unit cell, only one unit cell is what you see here. Such unit cell, 8 of them just over this one unit cell, that side one, 4 in this, then again in the next layer 4 will be there. This ball which you see is being altogether shaped by 8 such unit cell. Same way if you look at the second one, body centered, and don't forget, in addition to same diagram what you see here, empty in the middle, but here you can see one ball has come in the middle here, one ball, so that's why it is a body center. In addition to this 8 corners, which is 1/8, so this one is what is 1/8, and such 1/8 structure, 1 2 3 4 8 are there. So if I multiply this with 8, because one corner is 1/8 and such corners 8 are there, so as you cancel 8 and 8, so that is why if you really count the total number of unit cell, the total number of balls, the particle is what is 1. And in addition to this, there is also one ball which is in the middle, so plus 1, so the 1 plus 1, so altogether in a BCC, that is body centered cubic cell, 2 particles are there, whereas in a simple cube it is only 1 by 8 into 8, only this, only 8 corners are there, and that is what is equal to 1. So here you have only one particle. Now if you are asked what is the number of particle, or we call it as rank, we are going to see that also a little later. So what is the rank? Rank means total number of particle present. Then you may say, sir, 8, because we saw in the diagram 8, but actually it is not 8. So it is that one corner is 1/8, so 1/8 into 8 is what is 1. So total number of particle present in the simple cubic is 1, whereas in a BCC or a body centered cubic it is 2, and in a face centered, in addition to the 8 corners, so it is 1 by 8 into 8, so 8 corners, plus you also have at the 6 faces, and one face is equal to half, because one face, the ball at the face is shaded by 2 unit cell, so half into altogether 6 faces are there. So here you can see 1 plus 3, so altogether 4. So that means here if you are asked what is the rank of a simple cubic, it is 1, only one particle is present in this unit cell. In a body centered, what is the rank? In a rank in a body cell is what is 2, because 1 in the middle and then 8 corners, 1, total 2. And in case of your face centered, the rank is what is 4, total particle present. 6 faces is what is equivalent to 3, and 8 corner equivalent to 1. So that is what we call as the rank. So there it is. Just now what I said about corner is 1/8, in the body centered is exclusive 1, whereas in the face centered is what is half. So then the same kind of number of particle representation a little while ago we already saw. The same thing is what is one atom in one unit cell, so that is what is equal to 1. So this calculation we have done already. So 4 atoms, so there it is, 8 into 1 by 8 plus 6 into this one, that is what. So that is why this is what we call as the rank. What is the rank? What is the total number of atoms present in a unit cell? And it's not necessary that it's only atom, it can be molecules also, it can be ions also. So what is the number of atoms or ions or a molecule present? Then we can say here 1 unit, here in case of this is 2, and in this case this is what is 4, so 4 in case of standard. Okay, I think we'll close this one. I think in fact close packing of sphere, I think is going a little lengthy, so I think I'll discuss this close packing of sphere in the next class. Yeah, strangely, I think since many of you had reservations about coming online for a video conference, in fact, you have expressed your fear of using the Zoom app. Now, if not Zoom app, there are also other app. Then I think I told you people to discuss about what app you want to use for a conference. Because if we have a conference, then we can have an interactive session. It is just me only here, blah blah blah, going and showing you. As I said, I'm still using this technique, because when numericals will be coming, I have to use the board, because I cannot show you here because it's too difficult to show it here on the screen. But then if you have an interactive session, in some cases we can discuss question answers, maybe numericals we can discuss. But then since you people were not willing, so because of that only I have given up an idea of using the video conference. But then if you feel that there is a need, then you people discuss out with each other. That security issues, I think you people know it best. Dulara was very particular about security. So yes, Zoom app have security issues, but then as such almost every interactive teaching is to be done through Zoom. That is the easiest way. The easiest app to use is Zoom. Yes, if you want to go for other complex app, there are so many other complex apps where you can use that. But then again, the thing is that many of your phone will not support those apps. They are very heavy. Now when I say heavy, they uses a lot of your RAM, as well as also uses a lot of your phone space. And so because of that only, I wanted to have a trial with you with Zoom app. But since you rejected, and then I cannot force you into coming this one into that video conference. That's why I have given you. So the time when you realize, or the time that you decide that you want to do the video conference with me, I think I'll be more than happy. But then thing is that you all have to decide on which app to use. I am comfortable with any app you use. I can use my mobile, I can use my laptop. In fact, I have the provision of using any of the two. So whichever app you use, I think I'm ready. So let me know if you decide, or else if you want to see only this kind of a video where I'll only be doing the speaking and you don't want any interactive session, is fine with me. Okay, thank you. And yes, I'll be putting up just now in the form of the pictures I have shown you, but I'll also be putting up some animations for you to see, because in the initial phase we are going for this crystal chapter. I'm going very slow because it is very difficult, especially if I do not show you with respect to animation. I think it's very difficult to understand. So let's go a little slow. Once you understand the concept of a close packing, how the particles are arranged in different unit cell, then I think we can pick up, and then I think I can start with the classroom teaching. Yeah, thank you. Now let us see this in the form of animation. I told you about the crystal point, crystal lattice. We discussed about the particles. Now you can see these pink dots that you see, they are particles. Now particles means atoms, ions, or molecules. Now see how they are arranged one over the other one in the same layer or in different layers. Now these particles, how they are present there in the crystal is what you can see, the red dots flashing. Now lattice points are those red dots which are flashing. The whole structure that you see is what is a crystal, or we can call it as crystal lattice. Now those dots, as I have already discussed, they are points, they are atoms, molecules, or ions. Okay, then now what you see there is represented as a unit cell, and many such unit cells will combine together to give you the crystals. So now you can see that all those unit cells are what are filling up to make up the whole crystal. Now if you see that one corner, that is what is the unit cell. And as discussed, unit cells repeats itself. So many different unit cells are there repeating themselves to form the crystal. Now very nicely you can see through the animation is represented where different unit cells are combining together to give you. And then don't forget the lattice sites. Now look at one particular cell, unit cell. Unit cell, you can see 8 corners represented by those dots, and then I told you about two parameters of length, breadth, and height, that is represented A, B, and C, and the other parameter is with respect to angle, alpha, beta, and gamma. So with respect to length, breadth, and height, and with respect to alpha, beta, and gamma. Now let us see the particle which is there at the corner. As I said, it is 1/8 because 8 such unit cell will be sharing one. Now you can see very nicely 4 on the lower layer, 4 on the upper layer. So they are what actually combining together. That's why one particle that you see at the corner is altogether represented as 1/8 because 8 different unit cell will be sharing that one corner. Now if you go to face centered, the particle which is at the face is being shared by 2 unit cell. That is why I said face centered one particle is 1/2, half. So you can see there in the diagram, in the animation, so the face, both the face of 2 unit cells combined together is what is giving rise to one particle. Whereas in a body centered, the particle which is there in the center is exclusively belonging to that unit cell only. So that's why that particular particle which is in the middle is for that one particular unit cell. Now we discuss about primitive cubic unit cell. Primitive means the one which are there at the corners. So 8 corners, 8 different corners, 8 different particles. But don't forget that one corner is 1/8. Now why it is 1/8? Now see that one unit cell we have. So all this 8 corner parts, if you are taking and combining, see, that is what is giving rise to just one atom or one molecule or one ion. So that's why even though there were at 8 corners, but 1 by 8 into 8 is what is total 1 atom, or we can call it as 1 molecules or 1 ion. So that is what is the rank of a primitive cell. Now going on to the body centered. Now in BCC or body centered cubic cell, now in addition to the 8 corners, there 8 corners are there, and you already know 8 corners means 1 8 into 8 because they are being shared by 8 unit cell. You also have one exclusive particle in the center. So now there 8 corners, if you combine them all, then that is what is giving rise to your one particle. So that means we can say the rank in this case is one particle plus one middle one, the body centered one, the middle one, altogether that is what is giving rise to 2. So that is why the rank of a body centered particle is 2. So for a unit cell which is body centered, 8 corners plus 1 middle, so total rank is 2. Again I am repeating, rank means the total number of particles present in the unit cell. So there it is, 8 corners. 8 corners is equivalent to 1 by 8, and there are 8 corners, so 8 into 1 by 8 is what is 1 atom, and inside the body 1, so that is what is 1. Total is what is 2 atoms. So total number of particle present in a body centered is 2, or we say rank of a body centered is 2 atom. Now going on to the face centered, you have, in addition to the 8 corners, like in the other two cases, here also you have 8 corners. At the 8 corners you have those 5 particles present there, sorry, 8 particles at the 8 corners. Now if 8 particles are present at the 8 corners, we also have 6 faces. So at the 6 faces, altogether 6 particles. But such 6 particles, as you can see, altogether from the 8 faces 1 particle has come out. Now 6 faces, half of particles. Now if you combine this half of particles from the 6 faces, now you will see in the animation how this half of particles actually combine together to give rise to 3 particles. There 1 2 3. So already 1 from the 8 corners and 3 from the 6 faces. Altogether the total number of particles in your face centered cubic cell is 4. Now if you do the calculation, then we have the 8 corners, so 8 into 1 by 8 is 1 atom. Then in addition to this we have 6 faces. In the 6 faces, one face we will take it as half. Half into 6 is what is 3. So faces will consider 3 atom and the corners will consider as 1. So the total number of atom present in FCC is 4, or we say that the rank of a FCC is 4.